problem 9, we need to show that Yn is a Markov chain, where Yn equals to the summation of I to n xn. And we know that xn is IID, which is independent random variable. And based on the probability of Markov chain, we know that the current state is independent of all previous states, and the current state is only dependent on the previous one state. The previous one state, which represents in formula is that the probability of Yn minus 1 equals to j under the condition that y1, y2, yn is equals to the probability of yn plus 1 equals to j under the condition of yn. And since Yn is equals to summation of xn, we can rewrite this as Yn plus xn minus 1. And since in the previous formula we have both Yn here, because we are conditioned on Yn, so the only variable here is xn minus 1, and we have the condition that xn is independent random variable. So here we can rewrite this formula as the probability of xn under the condition that y1, y2, yn is equals to the probability of xn under the condition of yn, because xn is independent of all those terms here. And we can because we have previously stated that xn is equals to yn minus plus 1 minus yn. So we can then rewrite our equation as the probability of xn equals to yn plus 1 minus yn under the condition of y1, y2 to yn is equals to the probability of xn under the condition of yn. So here we have derived the requirement for a Markov chain, which is the current state is independent of all previous states. So this is the yes. So because we need what we need to show is that Yn follows a Markov chain. So here we can represent this equals to the probability of Yn minus 1 under the condition of y1, y2. Just rewrite this equation And since here xn and yn is independent of all later variables, so we can rewrite it is equals to the conditional probability of yn minus 1 condition on yn. So here we have complete our derivation of yn is a Markov chain. I think in this problem, what we need to pay attention is that we need to use the probability of xn is an independent random variable, and we need to be able to rewrite yn minus 1 equals to the summation of yn and xn minus 1. And we also need to use the probability that both condition on yn on each side, so we can just consider yn as a known variable here, and the only unknown variable is xn minus 1, and as the index can be shifted by 1, and so we can rewrite this form to remove yn and to remove yn and yn minus 1 here. So this will only be xn at here, and we can then use this should be n minus 1 here, sorry, n plus 1 here, and we can then represent xn plus 1 equals to yn plus 1 minus yn, and after some rearrangement we get that yn is Markov chain because it follows the probability of Markov chain.